Let's take a look at these three examples. This time we're supposed to convert the decimal form to engineering notation form. Keep in mind that anytime we do not have decimal point at the end of the number, we have to realize that there is always invisible decimal point, and anytime we do not have power of 10, there is always invisible power of 10, which is 10 to 0. Because 10 to 0 is equal 1. 1 times 8,600 is simply 8,600. In order to convert this number to engineering notation, we're supposed to have the number on the left side of the decimal point from 1 to 999. This number is greater than 999. So what we're supposed to do, we're supposed to make this number smaller by moving the decimal point. But if you are going to look at the exponents of powers of 10, there are multiples of 3. So we have to move this decimal point not one time, we have to move this decimal point 3 times. Why? Because I have exponent 0 over here. So I have to move 1, 2, 3, okay? Because I'm here, and I'm supposed to go to one of these, okay? But in this case, I have to make the number smaller. That's why I have to move my decimal point to the left. And I have 8.6 times 10 to the third. Why? Because anytime number is getting smaller, exponent has to get bigger. I move my decimal point 3 times to the left. That's why my exponent went up 3 times. I have 3 because I add 3 to 0 because I move my decimal point 3 times. Let's take a look at the second example. We have 270,000. My decimal point is over here, and I do not have power of 10. I have to just make it visible. It's 10 to 0. And again, the number on the left side of decimal point is greater than 999. So what am I supposed to do? I have to move my decimal point 3 times. Why I have to move 3 times? Because I have exponent 0 over here. Exponent 0. So the closest power is 3 or negative 3. But because the number is getting smaller, exponent has to get bigger. Number is getting smaller, exponent has to get bigger. That's why I have 270 times 10 to the third. The number on the left side of decimal point is between 1 and 999, and my exponent is 3. So this is the proper answer to my problem. Let's take a look at this example. Again, I have no decimal point visible, so I have to make it visible. I have no power of 10, I have to make it visible, times 10 to 0. And the number on the left side is greater than 999. That's why I have to move this to the left side. 1, 2, 3. Again, my number on the left side of decimal point is greater than 999. So I have to move another 3 times. 1, 2, 3. And let's take a look what number I have on the left side of decimal point is 432. So this is between 1 and 999. So this number is okay. So I'm going to copy this down. 432 times my power of 10. I move my decimal point 6 times to the left. My number gets smaller, exponent has to get bigger. So because I move my decimal point 6 times to the left, I have to add 6 to 0. 0 plus 6 is simply 6. Why? Because when number is getting smaller, exponent has to get bigger. Okay, my number got smaller. Before I had 432 millions. Right now I have just 432. Okay, and before I had exponent 0, it has to be compensated by exponent 6. Okay, so this is the solution to my problem.